You guys, in this video we're going to be going over some application attacks. We got cross-site scripting, SQL, LDAP, XML, and command injections. So in cross-site scripting, what's going to happen is an attacker is going to manage to get a victim to execute some bit of code. And this code is going to work across different websites that the user has open and steal, alter, mess up data from that user. You can see this a couple ways. What the attacker can do is send a link to the user saying, hey, come check out this website, we got some really cool stuff, blah blah blah. The user is going to go check out that website, and what will happen is that initializes a script from the attacker to start running on the user's computer. And typically this script is going to be done in JavaScript. That's very popular from attackers nowadays. They'll get onto the website, and within the website, or whatever link that the attacker sends, it's going to have something that executes the script automatically. So now the script can start looking at other browsers and other websites that the user has open, and it can start pulling your data. This can be especially dangerous when you consider bank data, all forms of account data that an attacker can pull. Now another version of this is called cross-site request forgery. In this, an attacker can leave some kind of cross-site script on a social networking site. This could be a chat room or like a series of chats from like Facebook per se. This could be a forum that's got a bunch of different messages from different users. And what will happen is when the user gets to a site like that, the attacker's post, or whatever it may be, is going to be filled with, let's just say, JavaScript code. So the website is actually going to run the code that the attacker put out there. So this makes it to where every single time a user gets on that site, that code that already exists is going to be run. And the same malicious script that was running from the other type with the link and whatnot to where it could steal data and etc., that will be performed also on the users here. So when we talk about injection attacks, as a whole, the attacker is going to take some of their code or their data and input it into a place that it shouldn't be. And as a result, they're going to get data returns from it. They're going to be able to mess things up, just do the stuff that an attacker would do. Right? So what will happen is, you can't just, typically you will not be able to just directly access a database. A lot of online databases you'll see have to go through a web server that the user's going to have to go through first, and then that'll communicate with the database. We'll put DB up here for short, and web right here. So if the attacker can put their data, in this example SQL data, onto the web server, and the web server communicates with the database is going to return with actual information that the victim wouldn't have intended, and that in turn is going to get back to the attacker. To more specifically analyze how this happens, the attacker is getting actual SQL code onto this web server. Well, that code is also being transferred to the database, and so now extra processes are going to be run on that database, which causes the extra return of data that goes back to the attacker. You'll see this on, anywhere an attacker can find out, how to get their user inputs, onto a web server or whatever it may be. That's where they're going to be trying to find ways to put in all their different injections. LDAP and XML injections work in pretty much the same way that an SQL injection does. LDAP is the lightweight directory access protocol, and XML is the extensible markup languages. Essentially, all you need to know here is that there are two different types of languages that attackers can use to the same purpose as the SQL injection. If they can get their own variations of LDAP and XML code in applications that use these two things, applications that'll run these two things, then the attackers can do any range of things from executing commands, modifying data, getting data, etc. If the application is not going to be able to register from the user or attacker, what is code and what is not, then the applications are in a lot of trouble. Really, the biggest thing that will help protect against these injection attacks is just filtering different user inputs out. If something that's going to interact with something SQL related, if an application knows it'll interact with something that's SQL related, it should filter out user input to where it takes out something or anything that looks like it could be SQL code. That way it doesn't run it by accident. So the command injection is just like the SQL, just like the XML and the LDAP injections. All it is just a different version of attackers being able to implement their code. Now this is done over web servers, right? Now if there are a bunch of directories in existence, the users should be able to see one of the ones at the forefront. If root was all the way over here, it's going to be directories away from where the user should be able to see or get to. So if the attacker can skip over, just what is able to be seen by the user, and web server might have some bad programming, have some software holes, might be malfunctioning, if they can get over directories, this is called directory traversal, and if they can get to root or something like that, they have a bunch of different things that they can do to mess up a server. Command injection is just going to be the use of a command shell, command prompt related code. Like SQL is its own thing. The command shell, command prompt, etc. That's its own thing too. So that's what the attackers will use in this instance to jump to different directories and get whatever they need.